Hey there. So in Python, we all know and love lists, right? They're kind of our flexible go-to tool for pretty much everything. But what happens when you need something a little more specialized? Today, we're going to look at two of Python's other data containers, tuples and sets. Think of them as special boxes designed to solve some very specific and very common problems that lists just can't handle on their own. Okay, let's just dive right in with a question. Imagine you've got a collection of data, let's say the days of the week. You know that list should always be Monday, Tuesday, Wednesday, and so on. What if you wanted to guarantee, absolutely 100% guarantee, that no part of your code could accidentally change Monday to Funday? How do you lock that data down? And hey, here's another one for you. Let's say you're keeping track of which students have turned in their homework. You only want to count each student once, right? Even if they accidentally submit their name twice. How do you build a list that just automatically says nope to any duplicates? Well, you're in luck, because Python has some really elegant solutions for both of these situations. So our first solution is something called a tuple. And honestly, the best way to think about a tuple is to picture a sealed box. Once you put your items inside and you close that lid, that's it. The contents are locked in, they're safe, sound, and not going anywhere. So here's the most important thing to get. A tuple is a collection of items, just like a list, and yeah, it keeps them in a specific order. But its real superpower is that it's immutable. Now, that's kind of a fancy word, but all it really means is you can't change it. Ever. Once it's made, it's set in stone. And making one is incredibly simple. Instead of the square brackets you use for a list, you just use regular old parentheses. See here? We've made a tuple called colors. Looks almost exactly like a list, doesn't it? But trust me, those parentheses make all the difference in the world. Okay, but here's where we see what a tuple is really all about. Let's try to treat it like a list for a second. We know the item at index 1 is blue. So what happens if we try to change it to yellow? In a normal list, this would be no problem at all. But with a tuple, bam! Python just stops you dead in your tracks with an error. And this isn't a bug, you guys. This is a feature. The tuple is doing its job exactly like it was designed to. It's protecting its data, it's enforcing that sealed box rule we talked about. So you might be thinking, why on earth would I want this limitation? Well, it all comes down to one word: safety. You use a tuple when you have data that is fundamentally constant. Think about it. The days of the week, the months of the year, a fixed school schedule. These things aren't supposed to change. And using a tuple makes sure your code can't accidentally mess them up. Okay, so we've solved our data safety problem. Awesome. But what about that other issue? The one with all the duplicate items. For that, we turn to our second special box, the set. A set is a collection with one simple but really powerful rule. Every single item inside has to be unique. No exceptions. No clones allowed. And there's another key thing here too. The items are totally unordered. Unlike a list or a tuple, a set really doesn't care about the position of its item. Let's see this in action, because it's actually pretty cool. To create a set, you use these curly braces. And notice what we're doing here. We are deliberately on purpose trying to put the number 2 into our number set twice. And check this out. This is the magic of sets. When we actually look at what's stored in that numbers variable, the duplicate 2 is just gone. Python enforces that no duplicates rule automatically the second you create the set. You don't have to write any extra code to check for it. It just works. Now, it's important to understand the trade-offs here. Sets are changeable. You can add and remove items after you've made them. But remember that unordered thing? That means you can't ask for the first item using an index like fruit's 0. A set just doesn't think in terms of first, second, or third place. So when is a set the perfect tool for the job? Well, anytime you need to absolutely guarantee uniqueness. Think about pulling a list of unique usernames from a log file, or getting a quick count of the unique attendees in a class. Sets are ridiculously efficient for these kinds of tasks. Okay, so we've met the flexible list, the sealed box tuple, and the unique item-only set. Now for the most important part, putting it all together so you know exactly which one to reach for when you need it. You know, this is the fundamental question every programmer faces when they start organizing their data. You've got these 3 excellent containers, but which one is the right fit for your specific problem? Let's break it down. This table really lays it all out. First up, how you make them. Square brackets for lists, parentheses for tuples, and those curly braces for sets. Easy enough, but the real differences are in how they behave. Need to change your data? Lists and sets say yes, but tuples are a hard no. That's their whole reason for existing. Need to keep everything in order? Lists and tuples have your back, but sets just don't care about position. And the big one, duplicates, only sets will automatically kick them out for you. So let's just boil this all down into 3 simple rules. Think of this as your cheat sheet. Use a list for your general purpose ordered collection that you know you're going to need to modify. Grab a tuple for fixed, ordered data that you need to keep safe, and choose a set whenever uniqueness is the absolute most important requirement. And that's really the key takeaway here. This isn't just about memorizing some rules, it's about programming with intent. Choosing the right data container, whether it's a list, a tuple, or a set, makes your code clearer, it makes it safer, and it makes it more efficient. It tells a story about what your data is for, and you know what? That makes you a much more powerful programmer.